Well, yeah,
If you need to make, if you ever need,
Second page is what we need to do. All right.
one swig for $20.
Oh, gross. All right. We are on the second page of the notes. It appears. Okay.
I was trying to get Ethan to do it.
So, are you ready? Today is definitely a calculator active day, so make sure you have your calculator out in addition to your notes. And you need to have your formula sheet because you've got these nice little formulas. I believe what I did on the test is I wrote the problem and then put the formula underneath. So you know what formula. Yeah. No. All right. So in the problem, as you read it, it says Sarah deposits $1,000 into an account paying 3.8% interest compounded continuously. Compounded continuously. Continuously is the key word. How much does she have after 5 years? So if we look at the formula sheet, we can see that one of them says compound continuously. That is PERT. PERT. People really say PERT. That's how they remember the formula. And so that's the formula we're going to use, y equals PERT. So I'm going to go ahead and write that formula down, y equals PE to the RT. It means that the interest is constantly being compounded instead of being compounded 3 times a year or once a year or 5 times a year or whatever. Continuously? So it's happening continuously?
If it's like 103.8% of 1,000, then the next year you would get 3.8% of that added on to the original.
But it's saying that it's continuously.
Yes, it goes on forever.
Yeah, that it's happening all the time.
But wouldn't
instead of just every day or.
If it's always being increased by 3.8%, then that would make it go to infinity, right?
Yeah.
What?
That it's happening infinitely many times per year. Yes.
But if you increase something by 3.8% infinitely many times, the answer is infinity.
No. We can look up how this works if you want, but we can't do it right now. We have to do the notes. All right. So if we look at this, we want to figure out what to plug in for each of the variables. So we know E is not a variable. That is 2.71. So we're not plugging anything in for E. But we do have to plug something in for P. What gets plugged in for P? 1,000. Okay. Nothing plugged in for E. What's plugged in for R? And so 3.8%, if you write it as a decimal, what would it be? 0.038, okay. And then what's the T? Yeah, 5 for 5 years. Okay, so we're going to say Y equals 1,000, so P times E to the R T. And then we can type that in. So PE to the RT. And what do you get? Yeah, I was going to say check for a typo because I got a different number. So I got 1209. Did you see if you had a typo somewhere?
Oh, yeah, I did.
Okay, there you go. Okay, so then we're going to go ahead and write our answer in context. Did I do that in the video? Write a sentence. Okay, so we're going to say Sarah has about $1,209.25 after 5 years. Okay. All right, how long will it take the account to reach $2,000? So what numbers are staying the same? Okay, so P is going to continue to be 1,000. R is going to continue to be 0.038. Is T going to continue to be 5 years? No, we do not know what the T is. And then what is the 2,000 now? Y equals 2,000. Okay. So now we can plug everything in. We can say 2,000 equals P times E to the R T. Before we do that, now think about, why would we not log base 1,000? The base is not 1,000, the base is E. Does that make sense? Yeah. So divide by 1,000, yeah. We have to make sure we get that base alone before we start logging things. Yeah. Okay, so 2,000 divided by 1,000 is 2. So at this point, we've already looked at the first step. There was no number to add or subtract over. We just did the second step where we looked and we could see that we divided the 1,000 over. And so the third step is our exponential step, log base E, which is actually an ln. Yep. Good. So ln of 2 is 0.038 t. Okay? And then what should we do? Yeah, perfect. All right. Could our answer be less than 5? No, because our previous answer was 5, and that was only $1,200. This is 2,000. This is more than that, so our answer should be more than 5. Okay, so what t value are you guys getting? Yeah, 18.241. Okay, so we're going to say, how long will it take the account to reach $2,000? It will take Sarah about 18.241 years to have $2,000.
That could just be rounded to 18.5 or something. Because, like, it's kind of excessive to round 3 decimal places for a time.
Yeah, but here we're not, the reason that we are doing 18.241 is because we want it to have an actual output of 2,000, not an output that's not 2,000. So if you did 18.5, then it would be an output that's more than 2,000. If you did less than that, you could say about 18 years. Yeah. Yeah. Yep. All right. There are 80 grams of cobalt-58, which has a half-life of 71 days. What does it mean when we say half-life? Yes.
A particle that it would take for about half of an object to radioactively decay.
Yes. So there are 80 grams of cobalt-58. It has a half-life of 71 days. How many grams remain after 250 days? So since it has a half-life of 71 days, that means that in 71 days, if it starts with 80 grams, in 71 days there would be 40 grams. All right. So we're going to take our half-life formula. So we have Y equals P times 1/2 to the T over H. And then let's figure out what goes in for each variable. So we have P. What is the P? Yeah, so that's the 80 grams. The 1/2 is just a number, and then what's the T and what's the H? T is 250, it's how much time you have, and then what's the H? 71 is how long a half-life is. Okay. So now we can go ahead and plug those numbers in. Y equals 80 times 1/2 to the 250 divided by 71. Are you allowed to do 80 times 1/2? No. Why not? Yeah. So, and order of operations tells you that you're supposed to do parentheses, then exponents. You're not supposed to do multiplication. Okay. All right, so let's go ahead and plug this in. We cannot say 80 times 1/2 is 40. We are not allowed to do that. So let's go ahead and plug this in correctly and see what we get. The reason I ask that is because there's always one person on the test who does it. So I just wanted to make sure that we're not doing that on accident.
Who volunteers to be the person?
That's a good question. All right. So how many grams are we getting? 6.968. Okay. So after 250 days, there are 6.968 grams remaining. Would an answer of 50 make sense? No. Okay. All right, it says how long until 1 gram remains. So what information is going to stay the same? P equals 80. H equals 71. What are we going to put for T? We don't know T. That's a question mark. And then what information is going to be new? Y is 1. Okay, what type of answer do you guys think is a reasonable answer? What might T be? You think T is going to be 1,000,000? That sounds like a sarcastic answer. Could T be, it's probably around what? 500?
It probably is more.
You guys think it's 10,000? Well, our previous answer was 7 grams remaining. This is 1 gram remains.
I mean, let me grab it.
don't graph it. I'm just saying, let's think about what reasonable answers could be. So, could our answer be something like 100 days? Could our answer be something like 200 days? Could our answer be something like maybe 300 days or 400 days? Could that's a more reasonable answer. Okay. Could our answer be something like -50? I'm just checking. These are the types of answers I get on tests. I just want to make sure that you guys are thinking as we do the problem. Okay, so let's go ahead and plug some numbers in. Think about how to do the problem. So we have 1 equals 80 times 1/2 to the t divided by h. And can I do 80 times 1/2 is 40? I cannot do that. Okay. So I'm not going to do that. So what should I do? Divide by 80. Anyone see what 1 divided by 80 is? Is it a nice decimal? Can we use the decimal?
0, 1, 2.
Do you guys want to use 1 over 80 or do you want to use the decimal? Okay, I heard more fraction than decimal people. Okay. Do you guys want to use 1/2 or do you want to use 0.5?
I am so OCD about that. I chose 1 over 80 because it has less characters in it than 0. Yeah.
No, but it's so hard to do that.
That's also how I decide to use. That's also how I decide where or not to use scientific.
There's a 0 in the decimal.
You don't have to use the fraction key. You can type 1 divided by 80.
But I always feel like I mess up when I do that.
That's fair. Okay, so we decided we're going to use 0.5. Okay, so now what do we do? Log 0.5, log base of 0.5 each side. Okay. So we have log base of 0.5 of 1 over 80 equals t divided by 71. So you do what with 71? Multiply by 71. Okay. $71. Oh, so our answer was not 10,000. You were close?
Yeah,
What did you guess?
500.
Oh, that is pretty close. So 1,000,000 was not very close, it turns out.
What about a gajillion?
That's not an actual unit of measurement.
Well, it should be.
Okay, so our sentence is. Our sentence is.
Have 1 gram remaining.
Yeah, I can't see. You can't see that. That doesn't sound safe.
What doesn't sound safe?
Roll 58.
Sounds like a gun.
You know that helium comes from the radioactive decay of uranium, and we have no problem installing that in our lungs.
Yeah, but
So, what do you guys
helium has a long
notice?
half-life.
How do you know when you're doing these problems? Listen carefully. What are they asking you to solve for when you're going to have to use a log to solve in the problem? Yeah, but which one? What are they typically asking you to solve for? Anyone figure it out? It's the t. If they ask you how long, if they said, how long did it take to do blah, blah, blah. Anytime they ask a how long question, you're going to have to use a log. Did you guys notice that? If you go back and look at all the questions, it's always the how long question that you have to use a log to solve in the problem. So the problems that don't ask you how long, the problems that are just saying how many grams, how much money, blah, 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 those types of questions are not Math 3 level questions. You could actually do those in previous years using these equations, and you probably have. You've probably seen these equations before and used them. The type of question that is Math 3 is the how long did blah, blah, blah. Those questions are Math 3 level questions, and those questions are what we learned this unit. So anytime it asks you how long, you are solving for an exponent, and that's what makes it the correct context for this unit. Okay, so that's kind of just a little key for yourself, is that if it's a how long question, you're going to use a log to solve it because you are solving for something that is in the exponent position. Does that make sense? Okay, so that might be something that you could add to your formula sheet just as a reminder to yourself, is that if the question is asking how long, you're going to have to use a log to solve it. If you don't use a log to solve it, you did something wrong, because you have to. Okay? All right, let me hand out the assignment. For today, when you finish the assignment, let me know, because then I'm going to have you guys get started on the test review. So we have this assignment for today, applications. Tomorrow is test review. And then that means that our test for this unit is on Thursday. Sound good? No video tonight because we are done learning for the unit. Cool. All right.